All right. This is chapter 3-1, and the title of this particular section is called Constant Rate of Change. Constant Rate of Change. All right, let's look at this table that we have in front of us. It's real simple. You can see that it's talking about money. It has a number of transactions on the left side and a balance on the right side. And what we want to do is determine whether or not this is a linear relationship. A linear relationship. Relationships that have straight lines for on a graph is considered a linear relationship. If I was to graph this, I want to know, will my line be straight or not? If I have a constant rate, it will be straight. If the rate is not constant, the line will not be straight. It's really, pretty straightforward like that. So let's get into it so you can see what I'm talking about. First of all, let's look at the number of transactions. It's going from 3 transactions to 6 to 9 to 12. Let's determine how this is changing. All right. From 3 to 6, it went up 3 transactions. All right. From 6 to 9, it goes up again 3 transactions. And from 9 to 12, it goes up 3 transactions. All of those are the same. So right now it looks like it's going by the same constant number of 3. It's going up by 3 transactions every time. All right. Let's look at what's happening with the balance. On the balance on the right side of the table, it goes from $170 to $140. So it went down. Therefore, I must use a negative number to denote that it is decreasing. It's going down by $30. Negative 30. From 140 to 110 is doing the same thing. And from 110 to 80 is doing that again. It's going down by $30. All right. So I want to determine if the rate of change is constant or not. Well, we can clearly see that the same thing that's happening on the left side is happening on the right side. So it is a constant rate of change. That means this is a linear relationship. That means if we were to graph it, you would see a straight line. But let's work it out a little bit further. This is what I want you to see. I want you to recognize that the left side here will be our X values. Unless they tell you otherwise, this is your X and this is your Y. When we graph it, that would be your axis. When we denote our answers, when we show our answers, you're going to write it as Y over X. So write it down like that in your notes, Y over X. Let's plug in the numbers for Y over X. The first time we see we have negative 30 and a positive 3, right? So let's write that down. Negative 30 over a positive 3. What does this ratio mean? Write it as a ratio, Y over X, negative 30 over 3. This means for every 3 transactions, my balance decreased by $30. That's how we would say it. For every 3 transactions on this side, my balance decreased by $30. What I want us to do now is reduce this. What would happen if we reduce it to have it in simplest terms? Let's divide both numbers by 3. And let me tell you why I'm using 3, because in my denominator, I want my denominator to have a 1. 3 divided by 3 is 1. Why do I want a 1? So that this can represent 1 transaction. All right, 1 transaction. All right, so what's happening in my numerator? Negative 30 divided by 3 is a negative 10. Remember, negative divided by positive is negative. This represents money on this side, right? So what does this mean? Every transaction, my balance decreases by $10. Every transaction, my balance. So that's like going to the ATM, withdrawing $10. Going to the ATM again, withdrawing $10. Going to the ATM for the 3rd time, I withdrew $10. That means that's a total of $30. Okay. So when we write our answer, this would be a negative $10 per transaction. All right. Or you could say a $10 withdrawal. You have to either say the word withdrawal or have the negative sign there so we know that the balance is going down, it's decreasing. All right. So hopefully you got that one. It's not very difficult, but you got to really, pay attention to showing your work on the sides there. Let's look at another one. All right. All right, let's do this here. Move this up here. Let's make this a little bit bigger. So let's see what's going on. All right, let's look at this particular example. All right, get my pen here. All right, so it says at the top, cooling water, right? One more thing I got to do here. Okay, there we go. Want to make sure that that went away. There we go. Now, cooling water. And then I have the time on the left side and the temperature on the right side. So let's work this out. I want to know if this has a constant rate of change or is this a linear relationship? It means the same thing. If it's a linear relationship, that means the rate of change is constant. If we were to graph it, it will be a straight line. Get it? All right. So that's what we want to know. So let's determine. Let's start with the times on the left side. It's going from 5 to 10. What does that mean? It's talking about time in minutes. So it went up by 5 minutes. I'm going to put a positive 5 over here. And then it does it again from 10 to 15. It went up by 5 more minutes. And then from 15 to 20, it went up by 5 more minutes. Let's see what's happening on the other side. My temperature is decreasing. Okay, so it starts out at 95 degrees Fahrenheit. That's what that F is for over here. So it went down by 5 degrees. All right, then from 90 to 86, it looks like it's going down again, but by 4 degrees. And then from 86 to 82, it went down again by 4 degrees. So we can clearly see it's not the same on both sides. All right, we know that the left side will be our X values and the right side will be our Y values, unless otherwise noted. That's the way it will be. All right, and so let's work this out. If, first of all, what kind of situation, what would have to happen in order for these numbers to actually do this? I think about having water on the stove. You turn off the stove, and 5 minutes later, you check the temperature. It dropped from 95 to 90 degrees. Then you check another 5 minutes, and it drops from 90 to 86. That's very possible. It's not going to be constant all the time. Okay, it can drop by 4 degrees or 3 degrees or 5 degrees. It can do whatever. And each time you check it, it may not always be the same. In this case, it's not. As the water's cooling down, it is changing. The rate of change is different. So let's write it down. So what do we have first? First, I have a negative 5 here, and I have a positive 5 here. So let's write it down. Negative 5 over a positive 5. So what does this mean? This means when the temperature went down 5 degrees, the 5 minutes had went by. My denominator represents my minutes in time, right? So let's reduce this. If I divide both numbers by, what should I divide by? 5. All right. The reason I'm dividing by 5 is because my denominator, I want to be a 1. Very important. That 1 represents 1 minute. Always look at my denominator first. All right, so now at the top, I have a negative 5 divided by 5 at the top here, and we know that's going to be a negative 1. And what does this represent? This represents degrees in Fahrenheit. All right. So in this case, when I reduce it, it's saying that in 1 minute, the temperature reduced by or decreased by 1 degree. Okay. It decreased by 1 degree in 1 minute. All right. Or per minute, the temperature will go down by 1 degree. Let's look at the next one. I have a negative 4 here and a positive 5 here. So now when I write that down, it looks like this. Negative 4 over 5. All right. So let's do the same thing. Let's reduce this. I know you're thinking the number 4/5 is a reduced fraction, but it's not in the format we want it in. So let me explain. My denominator right now says 5. That represents 5 minutes. Okay. My numerator says the temperature reduced by 4 degrees in 5 minutes. What would that mean per minute? That's what I want to know, because it's different than the first one we did up here. It's different than that one. So let's reduce it. I want to divide by what? What number should I divide by? 4 or 5? It's either going to be 4 over 4 or 5 over 5. Which one should it be? Remember what I said. Look at your denominator. That's your giveaway. That number got to be a 5. Therefore, the top has to be a 5. So watch what happens. Let's do the denominator first. 5 divided by 5 is 1. What does that represent? 1 minute. That's why I want to have that 5 here, so I can get 1 minute here. All right. What happens at the top? What is negative 4 divided by 5? You might need to work it out by hand, or you may need to use your calculator. But either way, you will get negative 0.8. Okay. And what does this represent? Degrees. All right. In other words, in 1 minute, it did not go down by 1 full degree. It went down by 0.8 of a degree, or 4/5 of a degree. 4 over 5 is the same as 0.8. So what's happening here, this is telling us that the first 5 minutes up here and the second 5 minutes here is 2 different rates. It is not constant. Okay? So here, this is saying that this is not constant. It's not a constant rate of change. Therefore, it is not a linear relationship. It is not linear. If we were to graph this, it would not be a straight line. All right. We'll be graphing these a little bit later, but for now, this is what you're going to need to do. All right. So hopefully you got those 2 examples. All right. That's it. Very good.